The example program we have been working on is an interesting one, as it helps us see how variables can be useful. If we look back at our program, you can see that as we draw each new rectangle, we have to calculate a new y-coordinate value to help position the rectangle with enough space around it. This helps us move our rectangle to an empty part of our canvas. But how did we come up with these values? In our first attempt, I've basically guessed as to what those y-coordinates should be. But as you can see, the gap is not really even, and although it's a good start, I'm sure that we can do better. What if we wanted to keep the space between the rectangles exactly the same as we increased their heights, but we want to be able to calculate it in our program? We can use a variable to help us here as well. If we think about it, we want to have the same amount of distance between each line. So when we calculate the new y-coordinate for the next rectangle, it should be the previous rectangle's y-coordinate plus the distance, plus also the height of the previous rectangle. We can use variables to help us calculate this by having a variable to represent the current y-coordinate that the rectangle is drawn at, as well as a variable to store the distance between each rectangle. The first thing that we do is create our canvas, again 120 pixels wide and 300 pixels high. We then create three variables, one called y, representing the current y-coordinate value for where the rectangle is to be drawn. The next variable holds a value which represents the distance that we want to keep between each rectangle as we draw it. And the final variable h is the height of the rectangle, as we had used before. When we run the code so far, you can see that we create the canvas, but there is no visible sign of the different variables that we've created. When we call the rect function to draw the rectangle, we then use the y variable in place of the y-coordinate value and the h variable in place of the height. This draws our first rectangle like so. In our next lines of code, we want to calculate the new y-coordinate for the next rectangle we want to draw, as well as the new height for that rectangle. We can calculate the new y value by thinking about where we want it to be and what data values we have in our program. We want the new rectangle to be 10 pixels below the first rectangle. This is the value of our distance variable. We can calculate this as the y-coordinate value for our first rectangle, or the current value of y, plus the height of that first rectangle. This takes us to the bottom of the first rectangle, plus then also adding in the distance. We can write this down with this expression. We can then calculate the new height just as we did before, and then draw our second rectangle. We can do this again to create a third rectangle and again a fourth. As you can see, this becomes quite powerful as we are able to execute these lines of code as many times as we like while maintaining the properties that we want to for creating our image, creating rectangles that are double in height each time and with an equal distance. In this example, we're using three variables in our program to control both the location and the height of our shapes. As we can see from this last example, using variables does make our programs a little more complex, but it also makes them much more powerful. We can see that it would be very easy to change the way that the rectangle height is calculated throughout our program. Imagine what would happen if we wanted the height of each rectangle to be multiplied by 10 each time. Would our program maintain its regular spacing? What we have done here is use our variables in expressions. We can use variables in all sorts of mathematical expressions based on whatever is useful to us in calculating what we need. In the code examples and the quiz questions in this section, you will see lots of examples where variables and expressions are used in calculations in our programs.